In this video, we're going to take a look at acid rain and find out what many of the causes of acid rain are, and then find out what the impacts of acid rain on ecosystems is. So acid rain has to do mainly with combustion. And the problem with combustion is that when we burn fossil fuels, so in factories, when we burn coal, when we're driving our cars, we're adding chemicals into the environment, so sulfur oxides and nitrogen oxides to the atmosphere. And that's these particles here. So within the emissions of exhaust, you'll see these particles. These chemicals mix with water vapor in the atmosphere and they become acids. And then when that water vapor falls as rain, snow, or sleet, it's acidic and it then causes trouble. So to understand a little bit about acids, we need to understand the pH scale. So the pH scale goes from 0 to 14, and anything that has a pH, or a power of hydrogen, of 0 up to 7 is considered an acid. So the closer to 7 the substance is, the pH is, the less acidic it is, and the further away from 7 it is, the more acidic it is. So for instance, battery acid has a pH of 0, the battery acid that you would have in your car. You don't want to get that on your skin because it would cause burns and it would eat through metal. Sulfuric acid is a pH of 1. Lemon juice and vinegar has a pH of around 2, so that's why it tastes sour. All acids taste sour, but obviously we're not going to taste all acids because some of them are very corrosive. Orange juice and pop are a pH of 3. Acid rain, it has a pH of 4.2 to be considered acid rain. An acidic lake has a pH of 4.5. Clean rain is actually a little bit acidic anyway because of the carbon dioxide mixing with the water, and it has a pH of 5.6. So it wouldn't be surprising that the regular rain would also be slightly acidic. Bananas are almost neutral, but they're around pH 5 to 6. A healthy lake has a pH of about 6.5, so almost neutral. Same with milk. Pure water has a pH of 7. 7 is neutral. That means that the substance is neither an acid nor a base. And then our bases are over here. You'll learn more about them later when you study further science courses, but bases are the opposites of acids. So seawater and eggs are actually pH of 8. So if the ocean became acidic, it would be very far from what it is supposed to be. Baking soda has a pH of 9. We use that to react with acids in our baking so that we can make cakes and bread rise. Antacids, so the things you would take if your stomach has acid in it and you're having heartburn, has a pH of 10. Ammonia is 11. Liquid soap is 12. Bleach is 13, so we're getting pretty corrosive now. You don't want to get bleach on your skin because it can cause irritation. And then finally, drain cleaner has a pH of 14, and that's very basic and very corrosive. So now the question is, what impact does acid rain have on an ecosystem? So it damages many ecosystems. If acid rain falls on plants, it can actually cause damage to their leaves, and then the plants aren't able to perform photosynthesis and grow and produce the food that they need and the food that we need because we rely on plants. It can kill fish. It can cause shellfish and things with a calcium-based like skeleton or exoskeleton to dissolve, and then that's a problem for oysters and crustaceans. Plants can just wither and die. It can also make the soil acidic so the plants aren't able to grow in the first place, and then lots of animals can become sick and die from acid rain because either they're not getting enough nutrients because the plants have died or for other reasons. Now, if you live in an area with a lot of limestone like we do, we won't have as much impact of acid rain on our ecosystems because the limestone has the ability to neutralize the acid. But the only problem is when the acid mixes with the limestone actually starts to erode away. So that's a problem. So what can we do? What kind of measures can we take to stop acid rain from being such a problem? Well, one thing would be to reduce combustion, so to convert to more energy efficient and green energies to provide electricity, to use electric cars, to walk when we don't need to drive, to carpool. All of these things would help reduce combustion, which would reduce acid rain. So there's tons of things that we can do, and we have to consider making choices that may not be as convenient, but will be better for our environment. So now the question is, what can you do? So we're going to now do an investigation over the next week or so, exploring acid rain. So we're going to explore the impact of acid rain on something, and that's completely up to you. We're going to use simulated acid rain, and our simulated acid rain is going to be vinegar, which is actually a bit more corrosive than acid rain, but it will do very similar things. So you might want to take a look at how acid rain affects plant growth, or surfaces like corrosion, like a metal. There's lots of different things you can do. You're going to select something to study, and you're going to use the Smarter Science framework that we're going to teach you how to use to help design your investigation. And it's going to be completely up to you what you want to explore.